All right, page 19 in your notes, please. We're on the very last page. We're talking today about scatter plots, line of best fit, and linear regression. So this is kind of the conclusion of our lines unit. It's one of the places that we use lines in the real world to analyze data that we've collected. So we're going to start by talking about scatter plots. A scatter plot is a graph that shows the relationship between two variables. Scatter plots are usually created when we gather data that has two differing measurements, kind of. So let's say I went out and I surveyed 100 people and I said, hey, I need to know your height and your shoe size. Okay, and I'm going to put all their information on my graph. So the first person I ask is really tall, so their height's going to be higher, right? And they also had a pretty big shoe size. So I plot their dot. And then I asked another person, they were kind of medium sized and kind of medium shoe sized. I asked somebody who was pretty short, and they had a fairly small, kind of medium shoe size. And then remember, I asked 100 people. So I actually have 100 dots on my graph here, and I'm looking for a pattern in the dots. Now notice that it kind of seems like people who are taller, for the most part, have a bigger shoe size. And my smallest shoe sizes are my shortest heights. And overall, if I were to draw a line through these dots, it looks like it has a positive slope. We call that a positive correlation. As X increases, that was my height, Y also increases, that was my shoe size. So if it looks like our data points kind of make a positive line, positive slope, we call it a positive correlation. Now, sometimes we're going to have data that goes the other way. So we might have a situation where let's say we're looking at vehicles, okay? And I'm comparing the age of the vehicle to the value of the vehicle. Well, we all know that brand new cars, for the most part, have a pretty hefty price tag. And if I were to look at an older car, it'd have a lower price tag. And for the most part, as a car gets older, it's worth less money. Now, we could have some wonkiness on here, of course. Let's say we have a really old car, but it's a fancy car. It might have a random dot way up here. Totally possible. I still look at the majority of my dots and I say, for the most part, as X increases, Y decreases. It looks like my data has a negative slope. We call that a negative correlation. Now, I could have data that has no correlation. I might go out and ask people, how old are you? And how many dogs do you have? And I might have some old people with a lot of dogs. I might have some young people with a lot of dogs. I might have some middle-aged people with a medium amount of dogs. And I really am going to have completely scattered data because there's no correlation between age and number of dogs. Okay, so positive correlation, my data is increasing. Negative correlation, they're decreasing. No correlation, the two items are not really related to each other. So those are scatter plots. When we have a scatter plot, we gather all our data, we put all our dots on the plot, and then we look for ways to analyze the data. So if we know that we have a positive or negative correlation, we can write a prediction equation called the line of best fit. We can use it to predict the value of a variable given the value of the other variable. So if I took my data here and I made an equation to represent this line, I could say, okay, now if I have a person who is 7 feet tall, how big do I guess his shoe is going to be? And Data analysts can use this to predict populations, financial information, all sorts of things that are important in the data analyzation world. And so that's what we're going to look at right now. I have a situation here. The table to the left shows the relationship between the depth of the lake and the water temperature of the lake. Okay, here's the depth and here's the water temperature. And if you think about the lake, if you're on the shore of the lake, the water usually feels a little warmer. And if you go into the deep part of the lake, the water usually feels a little cooler. So we can kind of anticipate our correlation right there, right? Well, we're going to make a scatter plot using these points right here. Depth of the lake is going to be my x-axis. And to get all my numbers to fit 0 through 15, I'm going to count by twos. Okay, and now I'm going to count, I'm going to do my y-axis. It is temperature in degrees Fahrenheit. I'm going to count, so I'm going to show you something. I'm going to make a little jag right here that says I'm cutting out a chunk of my graph. I'm going to start at 70 degrees. So I'm cutting out 0 through 70. I'm going to start at 70, and I think I can still count by twos. Let me check. 2, 4, 6, 8, 82, 4, 6, 8, 9. Yeah, it's going to fit. So I'm going to start here at 70. And that's how high I have to go. So I counted by twos on both axes. Now, it's okay to count by a different amount on the two axes. It makes your slope harder to work with. Okay, so if you're graphing a line where you know the slope, it makes your boxes count differently. But we're not even doing slope that way right now. So these don't necessarily have to match, but I do like that it worked out to be twos. Okay, now I'm going to put all my data on the graph. So I have a point at 0 and 85. I have a point at 4, 82, 7, 81, 10, 79, 12, 77, and 15, and 76. Now, notice that my dots don't line up perfectly. I wouldn't expect them to because this is real data, okay? What we need to do now is we need to find the line of best fit, okay? Line of best fit means it goes mostly through the middle of most of the points, and it usually touches a few good points. So I'm looking at everything here. If I put my line where my ruler is right now, my line is below all the points. That's not going to work. If I were to put it here, my line is too high. It's above all the points. I'm going to try to get right in the middle where it's kind of touching each point a little bit, and I'm going to graph the line. Now with an eyeballed, I did an eyeball line of best fit. Okay, this is just my best guess. And even now, I feel like I have it a little too high. But a line of best fit drawn by hand is a prediction. Okay, it's an estimate. Estimate is the word I'm looking for. It's pretty darn close, but it's not perfect. we're going to do it on our calculator in a few minutes. That one's going to be perfect. All right. So now let's look at generating our equation, because that's our goal right now, is to get an equation for the data. It says use 2 ordered pairs to make a line of best fit. I want to choose 2 ordered pairs that are touching my line really well. So I'm going to use this one, the point 085, and then I'm going to use this one, which is at 1079. Now remember to write the equation of a line. First we find the slope. We're going to subtract our y values, and we're going to subtract our x values, and we're going to end up with negative 6/10. So the slope of this line right here is negative 3/5. Now we're going to use that with our intercept. Look, we have a y-intercept in our data to write our equation. Y equals, actually let's do point slope form with our intercept point. So point slope form is y minus y1. Y minus y1 is 85 equals m times x minus x1. x1 was 0. I'm going to end up here, I'm going to distribute negative 3/5 x minus 0, and then I'm going to add 85 to both sides. So I end up with y equals negative 3/5 x plus 85. This is the equation for the line that we just came up with. Okay, now we're going to take our equation and we're going to make a prediction. It says predict the temperature of the lake at 25 feet. So what I have here, 25 is my depth. The temperature is what I don't know. I know my x value. I don't know my y value. I'm going to use this equation to find it. Y equals, or I could say t equals, negative 3/5 input my x plus 85, and I'm just going to type that into my calculator. I end up with y equals 70. Now what does that mean? Because our big purpose here is, what does this mean? That means at 25 feet, the lake will be about, remember this is an estimate, 70 degrees Fahrenheit. And we could make a prediction for any depth, right? We could say, well, what if we go to 22 feet deep? What if we go to 100 feet deep? We have all these options using our line of best fit to make a best guess about the temperature of the lake at any given depth. Okay, now we're going to do this again, but we're going to have our calculator do this work for us. Okay, I have the instructions for it right here. It says to find the line of best fit, and we call this linear regression, using our calculator to analyze the data. What it does is it averages the change between every single point, and it averages the slope over time, and it finds the best points to use and all the things for us. We can do it on our calculator. This is the most precise. Remember here, like, we picked some points that were mostly on the line. We picked where the line's going to be. Obviously, there's some room for error. Doing it on our calculator gives us a really precise equation to use. So the first thing that we have to do is enter our data. Okay, we're going to hit stat enter. We're going to enter the x values. We're going to enter the y values. And then we're going to go through this sequence of buttons to generate the equation that we're looking for. All right, let's turn the page and we'll do an example. Okay, and I actually folded my page just a little bit so that we could see the instructions while we're working through the problem. So here we have a problem. The table shows the number of people and their suitcases on 8 airplanes. And so we're looking for a relationship between how many people are on an airplane and how many suitcases they brought onto the airplane. Okay, so like maybe more people would be more suitcases. I think that would make sense. Fewer people might be fewer suitcases, but we really want to know like exactly how many. So I've got my table of data here. P, and this is going to be my X value, is number of people on the plane. S is number of suitcases on the plane. So we're going to go into our calculator and we're going to hit the stat button, which is right here to the left of your dial pad. And we're going to edit our list. Okay, so I'm on edit already. I'm going to hit enter. And now look, I have list 1 and list 2. I'm going to put my X values in list 1. I'm going to put my Y values in list 2. So list 1 is going to get 63, enter. 115, enter. 153, 192, 224, 297, 331, 375. There's all my X values in my table here. Now I'm going to go to list 2. I'm going to put all my Y values in, or all my suitcase numbers. 112, 209, 278, 302, 379, 500, 586, and 712. Okay, so there's my X list and my Y list. I've created this table in my calculator. Now, I'm going to hit the stat button to go back into my statistics menu. And I'm going to go over to calculate. And I want to do linear regression. So I'm going to go down to number 4 and hit enter. I want to use list 1 and list 2 because that's where I put my numbers in, right? I'm going to calculate it. And look what it gave me. It says y equals ax plus b, where a is 1.8 blah 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 and b is negative 16 point blah blah blah. But notice this y equals ax plus b looks like a linear equation where a would be my slope and b would be my intercept. So this question that says find the regression equation, we're going to use this to write the equation. We're going to say y equals, and actually it would be s equals because our data has an s. S equals my slope, negative 1.8342 blah blah blah. I'm just going to use 2 decimals, so 1.83 x minus, my b value is negative, minus 16.497, 16.5. Okay, that's rounded to 2 decimal places, and this actually would be p, so 1.83 p minus 16.5. Okay, that's my regression equation. I'm done with that part. The next question says predict the number of suitcases on an airplane with 500 people. So suitcases is my equal, my output. People is my input, and I'm curious for 500 people. So we're going to say suitcases equals 1.83 times 500 minus 16.5, and I'm going to calculate that. 1.83 times 500 minus 16.5. I get S equals 898.5. That means on an airplane with 500 people, there are going to be approximately 898 suitcases. Okay, Please pause the video here. Try number 2, and then 3, and then 4 on your own. And I'll put up answers in just a minute and let you check your work. And answers up so you can check your work, check your equations. And have a great day.